Now we've already done a little bit of work with this when we end up doing long division and we have repeated decimals come out. So we can take a look and just see what this might look like when we end up with a repeated decimal. First of all, let's take a look at a fraction, 4 over 15. Again, if we're going to follow our rules to turn this into a decimal, I need to put my numerator inside of my division box and my denominator outside. 15 cannot ever go into 4, so I put a 0 on the top. I'm going to add a 0 and a decimal. 15 can go into 30, but it can only go into 30 2 times. So 15 times 2 is 30. I subtract and I get 10. Well, 15 can't ever go into 10, so I'm going to add another 0, drop it down, and now I end up with 15 going into 100. Well, 15 plus 15 is 30, plus 15 is 45, plus 15 is 60, plus 15 is 75, plus 15 is 90, plus 15 is 105. So I've gone over at 7. I can fit in 6 times without going over, and 15 times 6 is 90, as we just said, and I subtract. Now right here I start to see a problem. I've got 10 again, which means that I'm going to end up with 6 at the top, and this process is going to start to repeat itself. We want to save ourselves the trouble of doing a never-ending math problem, and we can show that this repeats forever by using what's called a vinculum, and it's just a line over whatever repeats. And you notice on this example, I did not put the line or the vinculum over the 2 because the 2 does not repeat. It's the 6 that's repeating itself over and over and over again. So I just put the line over whatever repeats, and I'm showing that that number is going to go on forever and ever. It will never change. So use that vinculum symbol over whatever repeats to show that a decimal is a repeated decimal.